Okay, this video we have questions 6, 7, and 8 at least. We'll try and get through all those. And question 6, is the following one-to-one? And then explain your answer using the definition of a one-to-one function. So, in any of these types of problems, the best way to go about this is to simply graph the equation. So we have line 1, which I've turned on here, is the equation. And as I look at this, visually you're checking for the horizontal line test. If I can run a horizontal line through the entire graph, never passing through the graph more than once each time, then we have a one-to-one. As you can see in this case, this little zigzag up and down and up, we are crossing through that line several times at several points in the graph. So for that reason alone, we can actually say no, not one-to-one. Now, explain using the definition, the answer for that, there's a couple ways you can write that. You can say the inverse is not a function. Because remember, in order for a relationship or a relation to be a function, you must have exactly one output for every input. That was that whole like 1, 2, 3, 4, 5, 6, 7, 8. So we have like inputs, x's, and y's. In order for a relation to be a function, we can't say 1 goes to 5 and 1 goes to 6. That doesn't work. Okay? So if the original relation is a function, that's fine, but the inverse would be where we actually switch our x's and y's so that y is now our input and x is our output. So in this case, you might be able to say 1 goes to 5, 2 goes to 6, but 3 also goes to 5, and 4 goes to 8. That's a function, but the inverse is not. The inverse would be flipped around, where we now see that 5 would be our input as multiple outputs. So the inverse is not a function. The other way you can say that, just to solidify this, is does not pass a horizontal line test. Okay. So that's number 6. Number 7, we're going to do the same thing. Number 7, we're going to graph that. And you can see that on the horizontal line test, we have passed, because nowhere can I draw a horizontal line and pass through the graph more than once. So that means that we have, in fact, passed the horizontal line test. Is this one-to-one? Yes. And explain using the definition, you can say the inverse is also a function. You say something about, also say something about passing the horizontal line test, but at least talk about how the inverse is a function, or if it does not pass the horizontal line test, you would say something about how it's not also a function. Question 8 then, they come out and tell you the function given is not one-to-one. So it's asking instead for you to state a limit on the domain to enable it. So what that's asking us is very simple. Here's our graph. Clearly, this does not pass the horizontal line test. If we were to say restrict this domain so that we only looked at like the left half of this parabola, if we just looked at the left half, now we pass the horizontal line test. Same thing if we were to just look at the right half of the parabola. And we do that by restricting the domain. So the goal is, the key is finding how much of a horizontal shift we have. Or if there's no horizontal shift at all, if it's just negative 2x squared, then there's no shifting left and right. But you're looking for where is the vertex of this parabola. And in this case, that's at x equals -1. So what we're going to say is state the limit. The limit the best answer would be either x is less than or equal to -1, or you could say x greater than or equal to -1. Either one, you don't have to write them both. But it's whatever on that graph, it's whatever that x value is for the bottom or top of that parabola. So that is 6, 7, and 8, and 9 moves on to the next standard. So I'm going to pause here, and we'll cover the next standard 1, 3 transformations in the next video.